Preparing for a Wipro Technical Interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. Explain the 4 pillars of object-oriented programming with practical examples. The 4 pillars are encapsulation, abstraction, inheritance, and polymorphism. Encapsulation keeps data and behavior together while controlling access through methods. Abstraction exposes essential behavior and hides implementation details. Inheritance enables reuse through an as a relationship, although composition is often safer. Polymorphism lets one interface support multiple implementations, such as different payment methods. I use these principles to reduce coupling, improve testing, and make systems easier to extend without modifying stable code. While answering, define encapsulation, abstraction, inheritance, and polymorphism. Connect each to maintainability, reuse, extensibility, access control, and a practical example from Java, C++, or another language. Question 2. How would you find duplicate elements in an array efficiently? I would scan the array once using a hash set. For each value, I check whether it already exists. If it does, I report it, otherwise I insert it. This gives O(n) average time and O(n) additional space. If modifying the array is allowed, sorting first gives O(n) log n time and can reduce extra memory. When duplicates must be returned only once, I use a second set or carefully manage output. Make sure to cover the hash set approach, time and space complexity, sorting as an alternative, constraints involving memory, duplicate frequency requirements, and language-specific collection choices. Question 3. What is the difference between an abstract class and an interface? An abstract class represents a closely related family and can contain state, constructors, concrete methods, and abstract methods. An interface defines a capability or contract and allows a class to implement multiple interfaces. For example, an abstract employee class may share identity and payroll behavior, while payable can be implemented by employees, vendors, or services. I choose an abstract class for shared implementation and an interface for flexible composition and loose coupling. In your answer, compare state, constructors, method implementation, multiple inheritance, default methods, design intent, and suitable use cases, preferably using Java examples familiar in service-based development. Question 4. How do you detect a cycle in a linked list? I use Floyd's algorithm with a slow pointer moving 1 step and a fast pointer moving 2. If the list has a cycle, they eventually meet. If fast reaches null, the list is acyclic. Both time and extra space are O(n) and O(1), respectively. To find the cycle's entry, I reset one pointer to the head and move both 1 step at a time. Their next meeting is the entry point. Be sure to mention Floyd's tortoise and hare algorithm, pointer movement, why equality proves a cycle, complexity, null termination, and how to locate the cycle's starting node if requested. Question 5. What is normalization in DBMS, and when might you deliberately denormalize a schema? Normalization organizes data to reduce duplication and anomalies. First, normal form requires atomic values, second removes partial dependency on a composite key, and third removes transitive dependency. This improves consistency during inserts, updates, and deletes. I might denormalize read-heavy reporting data to avoid expensive joins and improve latency, but I would control duplication through reliable write workflows, refresh jobs, or database constraints. The decision should follow measured workload performance, not assumption. Focus on update, insertion, and deletion anomalies. Explain first, second, and third normal forms. Then discuss read performance, reporting workloads, storage duplication, and consistency risks of denormalization. Question 6. Explain SQL joins and write a query to find employees without assigned projects. An inner join returns matching rows, while a left join preserves every row from the left table and fills unmatched columns with null. For employees without projects, I would write select e.id E.name from employees E left join projects P on E.id equals P. Employee where P. Employee is null. I would index the join keys and verify that project assignments are unique or use distinct if the relationship can produce duplicate results. In your answer, distinguish inner, left, right, and full joins. Explain null behavior. Use a left join with an is null filter. Mention indexes and duplicate rows where relevant. Question 7. What is the difference between a process and a thread? A process is an independent execution unit with its own address space, while threads share the process's memory and resources. Processes provide stronger isolation but require more expensive communication, typically through pipes, sockets, or shared memory. Threads are lighter and communicate easily through shared objects, but they introduce race conditions and synchronization concerns. I use processes for isolation and parallel services, and threads for concurrent tasks within one application when shared state is controlled. Make sure to cover memory isolation, resource sharing, creation cost, context switching, communication, synchronization, failure impact, and examples where multithreading improves application throughput. Question 8. How would you prevent race conditions in a multithreaded application? A race condition occurs when correctness depends on unpredictable thread timing. I first minimize shared mutable state, then protect unavoidable critical sections with mutexes or language-level synchronization. For simple counters, atomic variables may be sufficient. I keep lock scope small, acquire multiple locks consistently, and avoid calling external code while holding locks to reduce deadlock risk. Thread-safe collections and immutable objects further simplify design, but I still test with stress and repeated concurrent executions. Discuss identifying shared mutable state, atomic operations, mutexes, synchronized blocks, locks, immutability, thread-safe collections, deadlock avoidance, and testing under realistic concurrent workloads. Question 9. What happens when you enter a URL in a browser? The browser parses the URL, checks caches, and resolves the hostname through DNS. It establishes a TCP connection, then negotiates TLS for HTTPS. The browser sends an HTTP request, receives headers and content, and parses HTML into a DOM while building the CSSOM. JavaScript may modify both trees, after which the browser performs layout, painting, and compositing. Caching, compression, connection reuse, and asynchronous resources strongly affect perceived performance. Cover DNS resolution, TCP or TLS establishment, HTTP request and response, browser parsing, DOM and CSSOM construction, JavaScript execution, rendering, caching, and performance considerations. Question 10. How would you design a REST API for an employee management system? I would model employees as resources. Get employees, id, post employees, PUT or patch for updates, and delete for removal. I would return meaningful status codes such as 201 for creation, 400 for invalid input, 401 for unauthenticated access, and 404 when absent. Pagination, filtering, validation, consistent error bodies, and request IDs improve usability. Authentication verifies identity, while role-based authorization controls sensitive operations. Be ready to explain resource-oriented URLs, HTTP verbs, status codes, validation, pagination, authentication, authorization, idempotency, versioning, error formats, and consistent API documentation. Question 11. What is the difference between authentication and authorization? Authentication answers, who are you? Authorization answers, what are you allowed to do? A user may authenticate with a password, multi-factor method, or identity provider and receive a token. The server then validates that token and checks roles or permissions before allowing an operation. I apply least privilege, short token lifetimes, secure storage, and server-side authorization checks. Hiding a button in the user interface is not a security control. In your answer, clearly separate identity verification from permission checking. Mention passwords, tokens, OAuth, roles, least privilege, token expiration, and protecting both user and service endpoints. Question 12. Explain garbage collection and common memory leak causes. Garbage collection automatically reclaims heap objects that are no longer reachable from live routes. Generational collectors improve efficiency because most objects die young, but collection can still cause CPU overhead or pauses. A memory leak occurs when unnecessary objects remain reachable, commonly through unbounded caches, static collections, listeners, or unclosed resources. I use profiling and heap dumps to identify retention paths, then add bounded caches, deregistration, and deterministic resource cleanup. Mention reachable versus unreachable objects, heap management, collection pauses, generations, references retained by caches or listeners, resource cleanup, profiling, and practical prevention strategies. Question 13. How would you optimize a slow database query? I first reproduce the query with realistic data and inspect its execution plan. I look for full table scans, expensive joins, poor cardinality estimates, and unnecessary sorting. Appropriate composite or covering indexes can help, but I consider write overhead and selectivity. I also remove unused columns, simplify predicates, paginate results, and verify updated statistics. After each change, I compare latency, reads, CPU, and concurrency rather than trusting an isolated benchmark. Focus on reproducing the issue, execution plans, indexes, selective predicates, join strategy, avoiding unnecessary columns, query rewrites, statistics, caching, and measuring improvements before and after changes. Question 14. What is the difference between a stack and a queue, and where are they used? A stack follows LIFO. The last item inserted is removed first. It supports push and pop, usually in O1, and is useful for recursion, expression evaluation, browser history, and undo operations. A queue follows FIFO, so the earliest item leaves first, and queue and dequeue are typically O1, making queues useful for scheduling and breadth-first search. I choose a deck when both end operations are needed and avoid array shifting for queue removal. Be sure to define LIFO and FIFO behavior, typical operations and complexities, implementation choices, recursion and undo examples, breadth-first search, scheduling, and practical trade-offs. Question 15. How would you approach a coding problem during a Wipro technical interview? I begin by restating the problem and clarifying input limits, duplicates, ordering, and expected output. I describe a simple solution first, then improve it using constraints and suitable data structures. Before coding, I explain the invariant and complexity. While implementing, I use meaningful names and handle empty, minimum, maximum, and invalid cases when relevant. Finally, I dry run normal and edge examples, test the code, and discuss alternatives. Discuss clarifying requirements, stating assumptions, choosing a brute force baseline, improving complexity, explaining edge cases, writing readable code, testing examples, and analyzing time and space complexity. Question 16. What is the difference between compile time and runtime errors? Compile time errors are detected before execution, such as syntax violations, incompatible types, or missing symbols. The compiler prevents the program from being produced successfully. Runtime errors occur during execution, including null dereferences, divide by zero, invalid indexes, or unavailable files. I prevent compile time issues through static checks and clear types, while runtime risks require validation, exception handling, tests, logging, and graceful recovery. Strong design reduces errors but cannot eliminate environmental failures. Explain when each error is detected, include syntax, type, linking, null, bounds, and resource examples, and mention compiler checks, exception handling, testing, and defensive programming. Question 17. Explain Git branching and how you would resolve a merge conflict. A Git branch isolates a line of development while commits record incremental changes. When a conflict occurs, I inspect the common base and both branch versions rather than choosing blindly. I edit the files to preserve the intended behavior, remove conflict markers, run formatting and tests, then stage and commit the resolution. I prefer small, focused branches and frequent synchronization. Rebasing creates a linear history, while merging preserves explicit integration points. Cover branches, commits, pull requests, rebasing versus merging, conflict markers, reviewing both changes, testing after resolution, and practices that keep collaborative development manageable. Question 18. What is CI/CD, and how would you improve a deployment pipeline? Continuous integration validates every change through automated builds, tests, and quality checks. Continuous delivery or deployment moves a verified artifact through environments, sometimes automatically to production. I would use reproducible builds, versioned artifacts, parallel tests, security scanning, protected secrets, and deployment health checks. Blue, green, or canary releases reduce blast radius, while automated rollback handles failures. Pipeline metrics such as lead time, failure rate, and recovery time guide further improvement. Mention automated builds, unit and integration tests, static analysis, artifact versioning, environment promotion, approvals, rollback, monitoring, secrets management, and faster feedback without sacrificing safety. Question 19. How would you design a scalable URL shortener or similar small web service? I would expose an endpoint that creates a unique short code and another that redirects it to the original URL. A relational or key value store can map codes to URLs, creation time, owner, and expiration. I would generate collision-resistant identifiers, place a cache in front of frequent lookups, and keep application servers stateless behind a load balancer. Rate limits, validation, metrics, tracing, and replication address abuse, reliability, and operational visibility. In your answer, cover requirements, short code generation, database schema, uniqueness, read-heavy caching, expiration, redirects, horizontal scaling, rate limiting, and observability. Question 20. Describe a production bug you fixed and the engineering lessons you learned. In one project, an API became slow during peak traffic because a cache miss triggered repeated database queries. I reproduced the pattern using logs and metrics, confirmed it with tracing, and identified missing cache protection around concurrent requests. I added request coalescing, bounded caching, and a database index, then validated the fix with load tests and gradual rollout. I documented the incident, added alerts and regression tests, and measured a substantial latency reduction. Be sure to structure the response with situation, diagnosis, root cause, corrective action, validation, communication, prevention, and measurable impact while demonstrating ownership and disciplined debugging. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.